So in this next proof, what we're going to do is take a look at a sequent that requires a little bit more sophisticated mixing and matching between the natural deduction steps for propositional logic and predicate logic. We've seen an example already where we apply a few steps from predicate logic natural deduction and then just complete the proof with propositional logic steps that we've learned earlier in the course. But in this example, we need to start with the opposite. We need to apply a particular technique from early on in the course, which allows us to then apply some predicate logic steps, which then allows us to apply some propositional logic steps. And so this mix and match between the two different frameworks, this is where you get some sort of complicated ways to go about proving things. So if we take a look at our one and only premise, it's a universal up front, and so we need a variable in order for us to eliminate that universal quantifier. And so instead we're going to take a look at a backward step. Now, at the outset here, at its core, it's an implication between an existential and a universal quantifier. And so the first step isn't a predicate logic one, it's a propositional one. In a backwards way, we want to do implication introduction. So if we're somehow able to go from exists a y, p of y, and deduce that for all x, q of x, then we're able to conclude line 4 here. Now we're in a situation where we have two options to us. In the predicate logic type of steps, we can either go forwards with the exists y or backwards with the for all x. The way I like to go about doing this is to take a look at what I'm going to be trying first in the forward pass to sort of peel off these universal quantifiers from my premise. And so this is a for all x, and it's q of x that it's aligned with. Now the x in the premise doesn't have to correspond at all to the x down here in the conclusion. It just happens to be aligned. You know, the for all x is inside of the q of x predicate here, but we might have swapped around those variables and it's equally valid. So the first step to take a look at is, you know, for all x, I'm going to try and remove this. The x appears inside of the q of x predicate, and so what is the q of x down here that I want to take a look at first? Well, line 2 is talking about p's of predicate p, not predicate q. It's line 3 that really talks about q. So I'm going to start with line 3 first. You could equally start with line 2, but this is a strategy just to make your proofs a little bit cleaner. So you're going to do a universal introduction. This introduces a variable to us now. We have an actual I, and we can use that variable to peel off the first universal quantifier from our premise. So we'll take the two of these together, and in a forward step, do a universal elimination. And so now we are in our second step. We need to apply the other removal of the quantifier inside of here. So we have an existential y p of y. In a forward, we can do an existential elimination, and this introduces a new variable. Now you don't want to just use the same variable I. Let me show you what it would look like. Before I do that, if you were to use the same variable I and try to do a universal elimination here, right, you wind up with something that says p of I implies q of I. Now there's no way for us to get p of I from this existential here. If we were to remove this, it's introducing a new variable. So when you do this second universal elimination, it needs to be on a new variable that helps you with the proof. So I'm going to take a step back, not do the universal elimination that way, but instead first do the existential elimination. It introduces a new assumption for us. We have an actual I1 now, and this is tied to PI1. Now when we do this universal elimination, we tie it to the new variable I1 and not just I. And in doing so, with our universal elimination, we now get something that is propositional logic and that we can start to use. So we have P of I1 implies that Q of I holds. And we have a P of I1 here that was done as part of that existential elimination. And so it's just a simple implication elimination. We get our Q of I as a result of that, and it completes the proof. So this is a slightly more complicated one than the ones you've seen previously inside of this section of the course, but it really shows you how at times you need to sort of mix and match the steps you're doing from the propositional logic natural deduction setting to the predicate logic natural deduction setting, and sort of interleave those in order to prove your entire sequent.